Southern Railfan is the place for amazing videos of all types of trains. Southern Railfan, subscribe today.
Okie doke, in this episode of our shelf layout, we're going to be building our bus and soldering our leads to the track. And we're going to show you the simplest, easiest, and cleanest way to build a bus and solder your wires to your track. We're going to be using, this is Radio Shack brand. You can get just about any brand of 60/40 rosin core solder. That way we don't need to use any flux, and we'll talk about why it's good not to use flux in just a bit. And the wire we're going to be using is 2-wire thermostat wire that you can pick up at just about any home improvement store. It's 2 colors. This one's red and white, and I don't know if it'll focus there or not. Anyway, there you go. It is solid wire. It's not stranded, so that's going to make it easier to solder and get a good hook bend on the end of the wire to come up and attach to a rail. Now, the only drawback to using the sheeted thermostat wire is you have to feed your wire from your bottom of your table or bench work up. You're not able to drill a hole and then stick your wire down through the top because, like I said, it has this protective sleeve on it. And we want to leave that protective sleeve on it because it really cleans up the bottom of your layout by not having just tons and tons of wires sticking out everywhere. So we're going to trim some of this back and get ready to solder in some leads. Alrighty, now that we're going to get started, always safety first. You need some kind of eye protection, and you really need to pay close attention to what you do with the soldering iron or soldering gun, whatever you want to call it. You can get where you're not paying much attention, and next thing you know, you've laid it down and you wind up touching it. And you'll know when you do that. Alright, there's 2 different styles of attaching feeders, and that's soldering the wires directly to the rail or soldering wire onto the rail joiner. Now let's look at the rail joiner soldering first. You can also talk about safety. I'm sure you can hear it in the background, the fans going. You really need some type of air to get the fumes away from you, because that rosin core will burn off and it makes smoke and fumes. On a rail joiner, let's see if I've got one already broke out. You want to solder your wire directly on to the bottom, and you'll need to do some kind of holder there to be able to hold this and do your solder directly onto the bottom. The only bad thing about these is if you ever want to move that connection, it's made onto it, and it's hard to get that off once you've got that on there. And it'll look something like this when you get finished with it. These are get to focus. There you go. Just right off to the side there. And these are Atlas, I think. They've got the little flap off to the side there just for that. But in your solder will be right there on the bottom. But we're going to concentrate on directly onto the rail. You want to pick you a spot in between the cross ties, and you want to be right in between the cross ties. And you want a drill bit just big enough to hold your wire that you've got coming up through the table. And then you'll take a piece of your wire, a piece of this thermostat wire, however long you need it, and we're going to cut back this plastic sheet that this is in. I'm just going to, with a razor, just cut that back, open it up. Cut that trim. And see, underneath your table, this is all you're going to see, except right there at your. And you want to come out about 1.5 inches, curl that back. If you come back about 1.5 inches and then cut up, that'll give you a pretty good distance there once you start pulling that through. And then just take whatever you're taking to get your wire cut back. I suggest wire cutters or wire strippers. What I'm doing is not the best method. I'll talk about safety, and then I'm cutting this razor back to myself. And you want to take about a little over about that much back, and you can take your dikes or pliers or whatever, and you just want to bend that in towards itself once you get that up through your table. And now we're going to go underneath. However you want to do that, I can just feel underneath the table here for mine and see where it's at. So I need red in the back. Let me fish this through here. See how easy that just pokes right up through there? And then you'll do that same thing with the other side. Alright, we got both our wires poked up through there. And you want to turn that wire straight that way in towards the rail. Same thing on this side. You want to make like a 90-degree turn in that wire. And if once your hole's right between the rail, you'll go ahead and tin. It's kind of hard to film, and you'll tin this wire and tin that one. That just puts a little bit of flux on it. And then you'll pull it down, and that's going to have just enough resistance to lean over and kind of pop that in behind the rail head. And that way, what happens is the force of that holds it to the rail head. And really, that's about as good as connection you're going to get. The solder part just guarantees that connection to touch. Okay, another tip. What I will do is I will take and use my rail as a resting spot for my gun or soldering pin, whatever. What do you want to call this thing? Iron. To let the heat go through into my wire first and then into my rail. But I'll pay close attention to make sure that I don't get too close to that cross tie because it'll melt. And once your solder starts to run, just lifts straight up. Now, when you do lift straight up, there's a possibility that can leave some excess solder on your rail. And one good way to tell is keep a spare car. And we got still just a little bit there, so we'll take some 1200 grit sandpaper and run across that and get that smoothed out. Now let's look at our running our wire underneath the shelf layout and building a bus. Okie doke. Underneath my layout, a lot of people, you can use those little terminals that have the several different screws on them that you can screw in there to connect your wires to. But the way I do it is I take a section of my thermostat wire and I take that outside cover off, and then I hold it up straight, and I've peeled the coating off on that side and the outside of the other wire. And then what I'll do is I'll just take that wire, the feed wire coming in, and strip it down about the length of a rail joiner and just set it right beside that and solder that together. And then I can take just a piece of electrical tape in there. Electrical tape's about that wide. Stick it in there and then just fold it over one way. Stick another piece of electrical tape in there and fold it over that way. And then I've got my wires coming out on each side. And then, you can bend that however you need to bend it and run it underneath your layout. And that makes it real clean, real easy. And you only have the expense of your wire and a roll of electrical tape. Those little, I forget what those things are called. Anyway, those little terminals that have several different screws in can get expensive. Now, another thing that I suggest you do, and that's the last thing we'll talk about, is mapping out your electrical system on your layout. So let's look at that now. Okay, mapping out what you're going to do on your electrical system, your DCC system, or even if you're running this many leads on your regular DC system. This is my, not exactly, but this is going to be my, say, shelf layout that I've got working here. I've got a line coming in this way, it goes off. This line comes in and goes around here. Now that's pretty easy to look at. This is going to be positive north and negative south. So I know I need to be positive up here, negative, positive, negative, positive, negative. Are you confused already? Yeah, that's what I thought. We'll get rid of this. This is the second biggest reason, other than keeping it clean and cheap, to use colored wire, which comes in the thermostat wire. Thermostat wire we use is going to be red and white. And it's to go by what's easiest for you is what your eye presents, red and white. So we know that the north rail, or the rail furthest away from us on each track, needs to have a red wire on it. The rail closest to us on each track needs to have a white wire. That's that simple. And it really comes in handy when you start having ovals and circles and track that's coming back in on each other, reversing loops, that kind of thing, to be able to remember by the color. Because if you look up here and do positive, negative, and down here you think you're going to do positive and negative, you're in trouble. Because you've made this rail here positive, but when you come around here to the bottom, you've made it a negative. So what you need to do is red and inside, or outside is red. That's what we're going to. Outside is red. Outside rail is red. About messed myself up there. Now, what you can do is when you start your layout, when you start drilling your holes, say you're going to drill a hole here and drill a hole here, go ahead and mark it R, W, W, R. And that way you know when you poke a wire up through that hole, it needs to be a red wire that's poked up through that hole. I hope that makes that a little more easier for you to understand. And the last thing I can tell you is at each one of my connections, when I get finished with this and get soldered in there, what I do is hook up I use an NCE system. I hook up my system and then run a train. And I know that connection's good. And so that's the way I do it. I undo. I don't put this directly to start tying them together yet. Each connection that I make, I test it. Now on my shelf layout, I'll overkill. I've got several different points of contact, and I just do that for myself. I think some manufacturers can say up to 12 feet, every 12 feet. So if you got a monster layout, long runs and stuff, I can see every 12 feet. But like this is a siding. If I've got a connection somewhere close to it, I'm fine. I'm not going to put a connection out here because I'm going to be shoving back into that siding. So I'm not going to have a locomotive go all the way to the back anyway. So I'm going to be more concerned with close to those switches. But if you got, a good, if you solder your joints and use not just the rail joiners, you could probably run the whole layout with just one connection. But I went a little bit overkill with that. So if you have any questions, email's in the description. Email me and I'll try to help you out all I can. And again, thank you guys for watching.